Moving on to example 7. Here, when I raise a power to a power, I multiply the exponents. So this is going to be called the power rule. When you raise an exponent to an exponent, and when you do that, you multiply the exponents. So 9 to the 4th to the 10th is going to become 9 to the 4 times 10, or 9 to the 40th. I'm raising r to the 6th, and that's being raised to the 3rd, so that's going to be r to the 6th times 3, or r to the 18th. Here my base is -3, so -3 to the 4th, that all raised to the 5th is, my base is still -3, but 4 times 5 is 20. -3 to the 20th. So that's the power rule when you're raising a power to a power. All right, so you're going to try practice 6. So when I'm raising, moving on to classroom example 8, here everything inside the parens is being raised to the 7th. So this is x is being raised to the 7th, and y is being raised to the 7th, and I've now removed the parens. That's why it's considered simplified. 3y to the 4th, that means 3 is raised to the 4th, and y is raised to the 4th. And we've already done this, or you can do it in your calculator. 3 to the 4th is 81, y to the 4th. These are equivalent, but this is simplified. Notice there are no parens. And here I'm going to have a -2 to the 3rd, p to the 4th to the 3rd, q squared to the 3rd, times r to the 3rd. Okay, -2 to the 3rd is -8. P to the 4th to the 3rd is p to the 12th. Q squared to the 3rd is q to the 6th. I don't want to make that look like a negative. R to the 3rd. So every factor inside of the parens is going to get raised to its power. All right, so when you multiply exponents, that's called the product rule. When you divide, that's called the quotient rule. But let's go ahead and just look at, before we get to that, let's go ahead and practice this. Not only when you multiply are each of the factors raised to the exponent, this would have the numerator, r, raised to the 6th, and the denominator, s, is also raised to the 6th. Notice now we don't have any parens. Everything inside these parens is squared. So that would be 5x to the 6th squared, and my denominator would be 9y to the 3rd squared. Now here, this is 5 squared, x to the 6th squared, and in my denominator, 9 squared y to the 3rd squared. So that's going to equal 25x to the 12th over 81y to the 6th. Now you will actually probably start doing some of this mentally. All right, we don't need to see all of these intermediate steps. I'm putting that there so that you understand the process, but you'll hopefully it will become more intuitive to you, and you'll be able to do these even without the writing the intermediate steps down. So go ahead and try practice 7. Looking at example 10, here's the quotient rule, which means division. And for that, you're going to subtract your exponents. If for the product rule, you multiply the exponents. For the quotient rule, you subtract the exponents. As long as they have the same base. All of these assume you're operating with the same base. So y to the 7th divided by y to the 3rd is y to the 7 minus 3, or y to the 4th. Let me just show you why that is true. That would be y multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. And y to the 3rd multiplied by itself 3 times. Well, you know y over y is 1, y over y is 1, y over y is 1. And what are we left with? Y to the 4th. So we might as well just use the quotient rule and subtract the exponents. This is going to be 5 to the 9 minus 6, or 5 to the 3rd. Same bases being divided, you subtract the exponents. Five to the 3rd, you could also say 125. 5 times 5 times 5. This is going to be negative 2 is my base, and 14 minus 10 is 4, which is 16. And here I have a 7 over 1, so that's just 7. My a's, that's a 4 minus a 1, so that's a to the 3rd. And with my b's, that's an 11 minus 1, so that would be b to the 10th. So simplifying this expression, the coefficient here is 1, 7 over 1 is 7, and subtract 4 minus 1, and 11 minus 1, and you get your exponents. So go ahead and try practice 9. That's practice with the quotient rule. Now, anything to the 0 power will equal 1, not 0. A very common mistake is thinking to the 0 power is 0. It's not. Any base to the 0 power is 1. Any base, no matter how complicated, to the 0 power is 1. Any base, even if it's negative, to the 0 power is 1. Let me come on over here. Any base, even if it's a decimal, to the 0 power is 1. But before you just go writing 1 just when you see the answer, this is negative 1 times 6 to the 0 power. That's negative 1 times 6 to the 0 power. And because of order of operations, we're going to do to the 0 power first. So this is the opposite, or negative 1. Anything to the 0 power is 1. So negative 6 to the 0 is actually negative 1. Same here. Even if a base is an exponent, is a variable, anything to the 0 power is only 1. So this is really like 5 times 1, which will be 5. So we actually like the 0 power rule. It's one of the easier ones. The only mistake is some people think it equals 0, not 1. So don't make that mistake. Okay, go ahead and try practice 10. And now let's evaluate this. If I was asked to do 2 to the third minus 2 to the 0, I'm not multiplying, I'm not dividing, I'm not raising a power to a power, so I'm going to have to actually evaluate what is 2 to the third. 2 times 2 times 2 is 8. Bring down your minus. Anything to the 0 power is 1. 8 minus 1 is 7. So 2 to the third minus 2 to the 0 is the number 7, the value 7. Anything to the 0 power, well, here we have a power raised to a power, so that's going to be y to the 0, because 0 times 7 is 0, plus 5 to the 0, because 0 times 3 is 0. Well, anything to the 0 power is 1. Anything to the 0 power is 1. So my answer is 2. All right, let's look here. So this is going to be 7 squared x to the 18th over 14 squared y to the 12th, which is 49x to the 18th over 196 y to the 12th. And 49 over 196 can be reduced to 1 over 4. So in my numerator, I'm just going to have x to the 18th, and in the denominator 4y to the 12th. So here I expanded, multiplied, and then reduced. I might have been able to make this an easier problem if I reduced first. Here my original problem was 7x to the 9th over 14y to the 6th squared. If I had started by saying 7 goes into 7 once, 7 goes into 14 twice, I could have rewritten this as x to the 9th 2y to the 6th squared. So here I reduced first, and now I'm going to raise that fraction to a power. That's going to become x to the 18th. 2 squared is 4. Y to the 6th squared is y to the 12th. Same answer. Here I reduced at the end. Here I reduced at the beginning. I like to reduce first because I don't really like working with the bigger numbers, but either way is fine. And then here, let's just take this slowly. This is 3 to the third. A to the 18th, because 6 times 3 is 18. B to the 15th, because 5 times 3 is 15. Over negative 27, a squared, b to the 4th. All right, what is 3 to the 3rd? 3 times 3 times 3. That's going to be 27, a to the 18th, b to the 15th, over negative 27, a squared, b to the 4th. Well, 27 over negative 27 is negative 1. With my a's, I'm going to subtract the exponents. 18 minus 2 is 16. And with my b's, I'm going to subtract the exponents. 15 minus 4 is 11. So that's your answer, negative 1, a to the 16th, b to the 11th. Or you could just write it as negative a to the 16th, b to the 11th. So again, none of these rules are very difficult, but pulling them all together and knowing when to apply product rule, quotient rule, power rule, zero rule, that's going to take a little practice. So you can go ahead and try practice 12.